When we look at this close-up of a vibrant orange sun with its active surface and massive solar flares, we usually see a life giver. A stable heat source like this is exactly what makes our planetary ecosystem possible. But turn your telescope away from our neighborhood and look deep into the cosmos, and you'll find celestial bodies that operate strictly as destroyers. High-energy radiation and gravity are often more efficient killers than a standard supernova. For many systems, the simple proximity of a specific type of star is enough to ensure total sterilization. Today, we are analyzing 3 apex killers, each using a different mechanism of destruction to identify the deadliest star in the known universe. By tracking these anomalies, we realize that deep space is a highly active, hazardous environment governed by lethal physical laws rather than a passive, empty backdrop. This wide-angle photograph shows the central band of the Milky Way galaxy. In a massive system like this, we expect stars to maintain predictable, stable orbits around the galactic core, but occasionally an anomaly breaks those rules. These are hypervelocity stars, rogue objects hurtling through the galaxy at speeds exceeding 2 million miles per hour. To understand how they get this fast, look at this diagram. It starts with a binary system, 2 stars orbiting each other, that wander too close to the supermassive black hole at the center of the galaxy. The black hole's immense gravity captures one of the stars. In the process, the orbital momentum transfers to the remaining star, which violently ejects it into deep space like a gravitational slingshot. If one of these rogue stars were to cross paths with a foreign solar system, its sheer gravitational pull would rip planets right out of their habitable orbits without the need for an explosion. A rogue star relies purely on extreme mass and velocity. It proves that kinetic force alone is enough to permanently sterilize a solar system. To find threats that rely on massive explosive energy, we have to look toward the constellation Sagittarius. This infrared image reveals a dense, glowing field of reddish-brown cosmic dust in that region. Nestled inside that dust is WR-104, pictured here as a pinkish crescent nebula. WR-104 is a Wolf-Rayet star, a hyperluminous giant at the end of its life cycle, rapidly shedding huge amounts of mass into space. Because it is shedding mass so quickly, its core will eventually become unstable. When it can no longer support its own weight, the dying star will cave in on itself in a catastrophic collapse known as a hypernova. As the star collapses in this diagram, it ejects extreme radiological energy into 2 narrow, intense beams from its poles, a phenomenon called a gamma-ray burst. WR-104 is a specific hazard because of its orientation. Astronomical observations suggest its rotational axis is aimed nearly directly at Earth. Even from 7,500 light-years away, looking at this full view of Earth, we are vulnerable. A direct hit from that gamma-ray burst could strip our planet's ozone layer, leaving the surface exposed to lethal cosmic radiation. WR-104 is a testament to the power of concentrated radiological energy. It shows us that vast physical distance from an explosion does not guarantee safety. While a gamma-ray burst is a brief, sudden flash of terror, other celestial bodies create a sustained, localized death zone. This brings us to PSR J1959 plus 2081, the original Black Widow pulsar. It earns its reputation through a mechanism of sustained parasitic consumption that effectively erases its neighbors over millions of years. A Black Widow is a special class of millisecond pulsar. It's a super dense neutron star that spins hundreds of times every single second, blasting out a relentless wind of high-energy relativistic particles. Notice the interaction in this diagram. The pulsar is locked in a tight orbit with a smaller companion star. The pulsar's intense radiation field strikes the companion, violently heating its surface in a process called ablation. Under that relentless bombardment, the companion star slowly vaporizes. The pulsar is actively stripping its neighbor atom by atom until it is entirely consumed. Black widow pulsars demonstrate a unique level of cosmic lethality. Their proximity creates a guaranteed, inescapable process of destruction that leaves nothing behind. The spectrum of destruction ranges from kinetic cannonballs and targeted radiological beams to pulsars that vaporize their companions atom by atom. Yet astrophysicists actively seek out these extreme phenomena. They serve as natural laboratories, allowing researchers to study nuclear physics under intense pressures and radiation levels that are impossible to recreate on Earth. As humanity eventually looks toward deep space navigation, knowing where these hazards are located will be a basic requirement for survival. We have to map out these death zones before we can plot a safe course through the galaxy. Charting the universe's ultimate stellar monsters is our first necessary step to safely exploring the cosmos. To continue mapping the unknown with us, subscribe to the channel and click the next video to see exactly what happens when two galaxies collide.